What is going on, everyone, and welcome to the Fusion 360 tutorial series. This is day 2 of learning Fusion 360 in 7 days. This tutorial is for complete beginners with Fusion 360 in order to learn the ropes from sketching our first component to assembling geometries by day 7. Today we will be taking a look at some more advanced sketching commands, such as the spline command, and learn where the revolve and sweep functions could be used instead of the extrude command in order to turn our sketches into 3D objects, all while modeling a vase to better understand these sketching and modeling techniques. Let's get started. But before we start sketching, let's take a look at how we can import reference images into our environment in case we ever want to sketch a particular shape from a physical object. The reference I'm going to be using is of this basic vase. So the first thing that I'm going to do is go ahead and select the canvas button that looks like a landscape from the insert section of the toolbar. And this window will appear here. We will press on insert from my computer, which will open up the file explorer, and we can go ahead and choose the reference image you want to insert. Upon pressing the button, you should notice that the coordinate origin in the middle illuminates, which, as we learned from the previous video, is Fusion's way of prompting you to choose a plane to put the reference image on. I will go ahead and choose the XY plane by hovering my mouse over the yellow square and left clicking. Now we can see that the image has been inserted, and this window of variables has opened for us to be able to modify the image we are inserting. In the navigation cube, let's press on the front label of the cube in order to turn the environment parallel to the screen for easier viewing. There are many functions that we can use in order to modify our reference image. One of them that we can change is the image's opacity by using the slider here. This will make the image more or less visible in our environment. I like to leave it at 50 so that I can see my image, but I'll also be able to see the lines I will be sketching over the image as well. Another option is the display through command, which controls the canvas image visible through other objects in the model. So when it's clicked or checked, you can see that the image regardless of the geometry that is in front of it. So I'll leave it checked for now. We also have the selectable functions, which allows the canvas to be selectable when working with other geometry. Unchecking this box locks the canvas so it doesn't interfere with the model. For this example, since I don't plan on moving the canvas, I will leave this box unchecked. The rendering function makes the canvas visible when rendering the model. If unchecked, the canvas won't appear in the rendered images. As for moving the image around, we have the X distance and Y distance, which will shift the canvas image along in the X and Y axes. This is useful for precise positioning of our canvas. And the Z angle will rotate the canvas image around the Z axis. We also have scale in X and scale in Y, which will scale the image in the X or Y direction. A value of 1 means that it has no scaling, and higher values make the image larger, and smaller values than 1 will make the image smaller. So for fun, let's scale the X by 2 to make this vase a little more rounded. Scale plane XY will uniformly scale the image in both directions, X and Y directions. And we have the horizontal flip and vertical flip, which will flip the canvas image horizontally or vertically. With all of these selections complete, we can go ahead and press on OK to confirm our choices. And there you go. We have inserted an image into our environment that we can use to sketch off of. Now let's learn about splines. Splines is like other 2D sketching functions, but instead it creates a smooth curve over or between user selected points. This is a very particular useful command since it allows for more flexibility to create complex, smooth, and organic shapes that would otherwise be challenging to achieve with basic straight lines and arcs. This is the perfect tool to sketch our vase with, so let's use them. To start, we need to enter and create a sketch, and we will do this by pressing on the Create Sketch button in the Create section of the toolbar. Next, we will be prompted to choose a plane we want to sketch on. Since I'm sketching based on the image I inserted earlier, I'm going to choose the same plane to sketch on by clicking on the yellow box that appears here. And now I've entered sketching mode. To insert a spline, we will go to the Sketching tab of the toolbar and head to the Create section. If we press on the Create drop-down menu, we will see all the 2D sketching functions that are available to us. Let's find the Spline command. Click it, and here we can see that we have two options for splines, a Fit Point Spline and a Control Point Spline. In a fit point spline, the curve passes directly through the points that are selected by the user, allowing for easier control when contouring or tracing. This would be particularly useful if we knew the pattern or point to trace over, such as sketching through the predetermined points on an airfoil outline. However, if these points are not known, this can lead to these lines appearing less smooth than the control point splines. In a control point spline, the curve does not pass directly through the points. Rather, the points act as handles to control the line that's passing near it. This allows for more subtle and smooth shape manipulation. This will be very useful in our case, since we will be roughly sketching the contour of the vase and then manipulating the smooth curve by moving the control points in order to get the desired shape. So let's go ahead and choose the control point spline command. If we leave the mouse stationary, we can see that it says specify the first endpoint of the spline. This will be one of our endpoints, so we will select the bottom of the vase, contour, and left click and pull the mouse outwards. We can see that a gray line starts to appear. Now, beside the mouse, we see specify next point, so let's select the next point somewhere along the contour of the vase. If we drag the mouse outwards again, we can see that the spline, which is denoted by the black line, is now taking shape. So let's keep selecting points alongside the vase until we get to the top. One thing to note, in areas where the contour does not change much, you can select less points in these areas. However, in the areas where the contour changes rapidly, such as the top of the vase, it is important that we select more points within our spline in this area, since it will allow for more precise control over the spline in these more critical areas. Once you're satisfied with all the points you have selected, you can select the white check mark that's located beside the last point you selected, and this will make the last point you selected the endpoint of the spline. As a result, you can see that the spline has been created. Now you'll notice that the spline that we created does not totally match up with the contour from the vase that we wanted from this image. However, we can easily adjust the spline by moving the control points of our spline. First, press on Escape to quit the spline command, or else you'll end up drawing a new one. And now we can move the control points of the spline that we created in order to match up the blue curve with the contour of our vase. There you go. I think that looks pretty good. Now let's learn about the Revolve command. The Revolve command is a powerful tool that will allow us to create 3D objects, like the extrude command that we saw in the last video. However, in this case, the 2D geometry is rotated about an axis to create the 3D shape. This makes it a particularly popular option when modeling cylindrical or rounded shapes. This is the function that we will use in order to build our vase, but first we need to create an enclosed 2D shape based on the spline that we created earlier. So to make this enclosed shape, let's start by looking at another powerful command. If you go to the Modify section of the toolbar and click on the symbol that has a blue line and a black line offset from one another, this is known as the Offset command. This will allow us to easily recreate the spline we recently created and give us some offset in order to create a wall that has thickness. So first things first, we will select the spline curve as a result. We can see a red spline of similar shape has appeared and is offset by 1 millimeter dimension. This red line is the target, or where the offset function will create the items that you have selected. We can control how far the new object will be offset by typing into the dimensioning box in the offset menu here. For fun, let's put in 2 millimeters. And we can also specify if we want the offset to happen on both sides by clicking on the checkbox here. And as we can see, by checking the box, the command will offset the line in both the left and right directions. We can also press on the two arrows here, and this will flip the direction of the offset if we're only having it offset in one direction, flipping it from left or right of the selected line. And finally, by clicking on the match topology, this will try to match the offset curve to the original curve selected while preserving all of its characteristics. If this is disabled, you are essentially telling the software that the exact shape is not critical and it can change the shape in order to get the offset that you desire. Let's see an example of this. If we select match topology and then we move the arrow to adjust the offset, we can see that the farthest distance that I can drag the offset is negative 2.564 millimeters, but then the software blocks it from going any farther. This is the limit of how far I can offset my geometry can be while it tries to preserve all of its features, and it looks more or less the same. If we unselect the match topology, we can see that we can now drag the offset as far as we want, but as a result, the offset does not look like the original curve and has lost all of its previous characteristics. So that being said, let's go ahead and choose the 2 millimeters as our offset towards the left while matching the topology of the original spline. Press on OK to confirm the choices, and there you have it. The offset has been created, copying the original shape of the spline that we initially made. Let's continue using the sketch functions to turn this into a closed shape so that we can later use the Revolve command as we mentioned earlier. Let's take the line command and start the line from the origin of the environment and drag it vertically downwards. Eventually, you'll see a dashed blue perpendicular line, meaning that the endpoint of the line that we are creating is perpendicularly aligned with the endpoint of the spline. So let's click on that to confirm the line and then press on the check mark to exit the multi-line command and press on escape to deselect the line command. If we hover over the line that we've just created and right click and select normal construction, this will change the line to a construction line as it will exclude it from interacting with our 2D geometry. This will be super useful for centering our sketches. Let's choose the line command again and create a line from the endpoint of the spline to the endpoint of the construction line. So let's create this line going vertically up from here by 2 millimeters, and then select the line command again, and we can sketch a line that goes from the top of the 2 millimeter line and drag it perpendicularly outwards and finish the line so it crosses somewhere over the second spline. Click to confirm the line, press on the check mark when we are satisfied, and there you have it. We have created the bottom of our vase. However, this corner doesn't look very good with the lines crossing over it, and we will run into problems when we try to turn this into a 3D shape. So let's clean this up. Go over to the Modify section of the toolbar and select the icon with the pair of scissors. This is known as the Trim command. This command will allow you to trim away axis lines that extend beyond desired boundaries. So by selecting the command and hovering over the end of the line here, we can see that the line turns red up until the closest intersecting line to it. This means that the command will trim away all the red part and keep the blue part of this curve. And by simply click, the trim function will execute, trimming away the part that's unwanted. We can do the same for the other overhanging line here. And there you have it. We have learned how to use the trim command in order to clean up the corners from unwanted curves, which is very useful when the exact location of the corner between two curves is not known. Now with the bottom of the vase created, we can move on to the top of the vase. So let's take the line command again and begin the line from the endpoint of the outer spline and drag it perpendicularly to the left to have it intersect with the line beside it. Then we can use the trim command like we did last time to trim away this corner. And there you have it, a closed sketch that has been created representing the cross-section of our vase. As mentioned, you can tell that the sketch is enclosed by the blue shade that has been added between the lines. If the sketch was not closed off, this blue color shade would not have appeared, which will lead to problems when trying to convert it to a 3D geometry. Actually, the program will just not let you do that, so keep that in mind. With the sketch created, let's go ahead and press on the green check mark in the toolbar to confirm the sketch. And now it's finally time to use the Revolve command. So let's select the icon beside the extrude command that looks like a blue 3D arc. We can see that this menu appears here. Since we've selected the 3D command right off the back of doing the 2D sketch, we can see that it has already chosen to this sketch to base the 3D geometry off of, as noted by the bright blue shade. Let's now press on the select button beside the axis and choose the green, or otherwise known as the y-axis of our environment. This will rotate the sketch about this axis. As you can see, it has provided us with an example of what the shape is going to look like, but we also have a couple of controls that we can play with in order to control the revolve function itself. The extend type allows you to control over a specific number of degrees you want to extend the revolve around. So in angle, if we were to input 90 degrees, we can see that the sketch has only revolved 90 degrees around the y-axis in one direction. If we were to change the direction to 2 sides, then we could specify how far we want the revolve of our sketch in the other direction, and this magnitude of the revolve doesn't have to be the same as the first one. Or contrarily, if we choose the direction as symmetric, this would revolve the sketch in both directions by the same specified amount. In extend type, we can also have the option to extend it to a certain body, which would be useful if we had other geometries within our CAD. Or we can just choose full to revolve the sketch 360 degrees about the axis, which is what we will do to get our vase shape. Press on OK to confirm the command, and there you have it. We've created a 3D object while learning how to use the Revolve command while sketching off of a template. However, there's a bit of a problem because I don't really like how the base of my vase looks. So let's use the sweep command and see how it might be able to fix the base of my vase. The sweep command is another very useful command that, similar to the extrude command and revolve commands, can be used to create a 3D geometry based on a 2D sketch. However, this is accomplished by taking the 2D profile and extruding it along a specified path. This is particularly useful when creating linearly directed curves, objects such as pipes, wires, and handles, which we can also add a twist angle to, which will turn the 2D sketch as it is swept along the 3D trajectory. But for now, let's keep it very, very simple. Let's see how we can use the sweep function to fix our vase. So let's go ahead and create a sketch. So let's re-enter sketch mode and press on the XY plane to sketch on it. We can then take the circle command and sketch a 2.5 millimeter circle near the bottom of the vase. We can now use some constraints in order to connect this enclosed shape to the existing 3D geometry. Constraints are these red icons here in the sketching toolbar, and they're essential in sketching because they help us define relationships and control the geometry of the sketch. Some of the most popular constraints are coincident, which is the second icon here. This constraint forces the point or line endpoint to connect, essentially ensuring that the parts of the sketch are completely aligned. There's also concentric, which constrains or forces two circles or arcs to share the same center point. And there's the tangent constraint, which forces a line to touch a curve at a single point, which can ensure a smooth transition between elements within our sketch. Constraints are particularly useful for more complex sketches, so I can encourage you to explore them when you get the chance. As for us right now, let's use the coincident constraint to show how it can be useful to center our sketch on the 3D geometry that we have. So let's select the coincident command, then select the center point of my circle, And let's hover the mouse over the bottom edge of my vase. We can see that another point will appear here. Select this point, and as a result, we can see that the circle snaps to the specified location and becomes completely or fully defined as noted by the sketch turning black. So now you may be wondering, why didn't I just sketch my circle with its center point at the bottom of my vase? Well, if I take the circle command and hover my mouse near the bottom edge, like I did with my constraint earlier, we can see that the center doesn't actually snap to any particular point. This is not actually a corner down here that we're able to snap to. This is the power of using constraints, since it not only considers elements that we're sketching, but also takes into consideration how the sketching planes interacts with the existing 3D geometry. In this case, since the sketching plane is cutting our solid down the middle, it recognizes that there would be a corner here rather than just a circular edge, and allows this to be a point of reference while using sketching constraints. All of that being said, now that the sketch is completed, we can see how the sweep command can be used in order to turn the sketch into a 3D solid. So let's exit sketch mode, and in the create section of the toolbar, if we press on the drop-down menu, we can select the sweep command, and this window will appear here. For our vase, we will use a single path sweep command. If you press on the drop-down menu, you can see that there are other types of sweeps that we can use, but the single path sweep will definitely be the common one that you will use. If ever you want me to review the other types of sweeps, just leave a comment below and I can make another video explaining exactly that. The profile, this will be the cross-sectional area or the sketch you want to sweep along a path. So in this case, the profile will be the circle that we just sketched before, and the path will be the line that we want to sweep it along, which in this case will be the bottom edge of my vase. So select that edge. To go over the other selections in this menu quickly, the chain selection is useful as it allows you to select a path consisting of multiple curves or segments. The distance describes how far along the curve you want to sweep the profile. 1 means that you sweep it along the entire length, and 0.5 means you sweep it across half the length of the path. Taper angle allows you to control whether you want the profile to increase or decrease in cross-sectional area as it's swept along the path. And twist will allow you to twist the profile along the same plane as you are sweeping it along the path, which is not particularly useful since we have a circular cross-sectional area in our particular case. Orientation allows you to control how you want the profile to interact with the path. Perpendicular means that each cross-sectional area will be perpendicular to the path at any given point, and parallel means that the cross-sectional area will always remain parallel no matter the curve path that it is following. An evidently operation, like the extrude function, allows you to control what you want to do with the command, whether you want to create a 3D shape or remove material from an existing solid. In this case, we will join the command and press on OK. And as you can see, now the profile or the circular shape has been swept along the base of our vase, spicing up our vase a little and making it a little more interesting. Pretty nifty. Now let's switch gears a little bit. We have a nice vase here, but wouldn't it be cool if we can add a little message to the side of it? Well, we definitely can do that. First, let's figure out how to add text as a sketch. To do this, let's go ahead and create a new sketch. And let's select the XY plane as our sketching plane. And in the create section of the toolbar, we'll press on the drop-down menu and press on text. You can see that we have two options for text. Either we just have a generic text function, which allows us to place a text box in the environment like we would do for any other Microsoft document, or we can also have a function that allows us to create text that follows a curve, but for this you would have to already have the path created or sketched. So let's go ahead and just choose the regular text box. We can insert the text box just by putting it into the environment like you would for any other document. So click, drag it out, and click again. This will prompt you with the text menu to pop up. And here we can add the text that we want to add. So I'm going to type hello world, and we can also change the font. So let's pick something nice. We can also make it bold and italicized, and we can also change the size of the font by changing the height of text. And we can also adjust how far apart we want our letters to be. The flip command allows us to turn the text in whichever direction we may desire, and the alignment allows us to align the text within the text box that we've created. So let's just center it in every direction, press on OK, and now we have a sketch that looks like other sketches that we have created, but this time it has text in it. Using the sketching constraints, we can align the text box to the center of our vase. Using the coincident command, like we did last time, press on the center point of the bottom edge of the text box, and then select the origin of our environment. As a result, you can see that the text box will snap to this location and has aligned the text to the center of the vase. Now let's take a look at the command that will evenly and easily extrude our text over the curved surface of this vase. This is known as the Emboss command. First, let's exit sketch mode and press on the drop-down menu in the Create section of the toolbar. And press on the Emboss command. First, you will be prompted to select the sketch profiles you want to emboss. This would be the text sketch that we just created. Next, we need to select the surface we want to perform the command on. So press on Select beside faces and then select the face of the vase. Now we have two options on how we want to emboss the text onto the surface, either by extruding it out onto the surface like this, or we can press on the recess command, which is also known as a deboss, to cut away from the surface or the solid. But for now, let's just leave it as an emboss command. And we can modify the height of either function by changing the value here, like we would for any other extrude function. We also have the option to change the alignment of how we want this command to emboss the provided text, but since we've centered it before, I'm just going to leave it as is here. We can press on OK to confirm our choices, and there you go. We have added the text to the side of the vase, which follows the same surface curvature. Very cool. Now with our vase created and we have etched a nice message onto the side of it, that will have to conclude day 2 of learning Fusion 360 in 7 days. It has been quite the jam-packed day, learning a whole bunch of other extrude commands that allows us to turn 2D sketches into solids in a variety of ways. Look out for day 3, where we'll go into what parametric modeling is and how it can greatly improve our CAD models. But that will be it for now. Don't forget to like the video if you guys thought it was helpful, and subscribe for more engineering content.